Okay, so in this lesson, we're going to be solving logarithmic equations. So we've gone over how to solve an exponential equation. We're going to go over to how to solve a log equation. So it's very similar to exponentials. There's several ways of solving these type of equations. So the first way that we're going to look at is equivalent bases. So solving logarithmic equations using equivalent bases is when the equation is written or can be written in the form log base b of something equals log base b of something. So if your bases on your logs match, that means that this x will equal this y. Okay, so you can set them equal, solve for x that way. So example 1, notice I have a log base 2 on the left and a log base 2 on the right. So I know that this part has to equal this if both logs are equal. So I'm going to set 5x minus 9 equal to 2x plus 6. And now I just have a linear equation. I'm subtracting 2x. That's 3x minus 9 equals 6. Add 9. You get 3x equals 15, so x will equal 5. Now, whenever you are solving a log equation, you need to make sure this term is not a negative. We can't have a negative there. So when we find our solution, just make sure it doesn't cause that to be a negative in that spot. Okay, so looking at next one. So notice I have a natural log, which means it has a base of e, and I also have a natural log on the other side, which means this piece has to equal that piece. So x over 2 has to equal 4x minus 7. So first I'm going to get rid of the fraction by multiplying by 2. And I have to multiply that by everything on that right side. So that's 8x minus 14. So now it's linear. I'm subtracting 8x. That's negative 7x equals negative 14. So x will equal 2. Again, just double check and make sure when you plug it in there that both of those are positive, and they are. Okay? So that's one way of solving a log equation. So that's if you have a log on the left, a log on the right, and the bases match. You can just set your x equal to your y. Another way is using inverse properties, which we've talked about. It's also called exponentiating both sides. So you're going to solve logarithmic equations by exponentiating both sides, which means you're going to be taking a base and raising it to that power. So that way you can use inverse properties. So your first step is to isolate your log term, and then you're going to exponentiate both sides, which means you're going to raise it to that power using the same base as your log. So notice it says same base as your log term. So that way they cancel out, and then you can isolate your variable and evaluate the expression. Okay, so first step is to isolate our log. So I'm going to circle my log. So that means I need to subtract 2 first. And I get 32, divide by 4. And I get natural log of x equals 8. Okay, so once we isolate the log, then you're going to exponentiate both sides, which means you're going to, whatever the base is of this log, which is e, I'm going to change it to exponential. So I'm going to do e raised to this power, and then I'm going to do the same thing to the other side, e raised to this power. So I am looking at my base, and then I'm raising it to this power and raising it to this power, so using the same base. Since these bases are equal, we've already talked about this on exponential, we can set those equal to each other. Actually, these cancel out, so I just have x, and that gives me e to the 8th power. So I can use a calculator to evaluate that. So the e button is second natural log or second divide. So whenever you do e to the 8th power, you should get 2,980.958. Okay, so the reason we exponentiated both sides is so that way these would cancel out, and then I'm just left with my x there. All right, let's try another one. So I'm taking my log, all of that, it belongs to the log. I'm going to subtract 1. Once I've isolated my log, I'm going to look at my base of my log. It's 5, so I'm going to change it to an exponential. So 5 is my base. I'm taking the log base 5 of 6 minus x. And then I have to do the same thing to the other side. So I have to raise it, change it to exponential. My base is going to be the same, so 5 and then squared. So those cancel out. That's the reason why we did that. We get 6 minus x equals 5 squared is 25. So now I just have a linear equation. I'm solving for x, so I'm going to subtract 6. And then divide by -1, so we get -19. Now, remember I said make sure that when you find your solution, make sure it doesn't cause this to be negative, and notice it doesn't because you're doing 6 minus a -19. So that would be good there. Okay, last one for this section. So notice that I have a log on one side and a log on the other, so I can't isolate them, but I can go ahead and go straight into changing it to an exponent. So my base of this is 10, so I'm going to do 10 raised to this power, and then I'm going to do 10 raised to this power. So these cancel out, I'm left with 5x, and notice also these cancel out, and I'm left with 4x plus 7. So I'm going to solve for x. That's x equals 7. Notice it wouldn't cause this to be negative or this term. You can also check it on the calculator by plugging in that 7 for x and making sure the left side equals the right side. Okay, so that is exponentiating both sides, which just means you are looking at the base of the log, changing it to exponential, using that base, so that way you can cancel out using inverse properties. Okay, another way is rewriting. So we can solve logarithmic equations by rewriting. Remember, a log can be written as an exponential, and an exponential can be written as a log. First step is to isolate your logarithmic term. Then you're going to rewrite an exponential form to unlock your variable, so then you can isolate your variable to solve. Okay, so first step is to isolate my log. Notice it's already isolated, so then I want to rewrite it in exponential form. You always begin with the base, and this one my base is 10 raised to this power, so the third power equals this. Okay, so that's going to give you 1,000 equals 3 minus 2x. And then I forgot the x. And then we are getting x by itself, so we're going to subtract 3. So that's 997 equals negative 2x. So when you divide, you should get negative 498.5. If you look back when you plug in here, that's going to end up being a positive because you're doing negative 2 times that negative of 498.5. Okay, doing the next one. So first we have to isolate the log. We didn't have to do that in the last one because the log was already isolated. So first I have to subtract 5. Then divide by 2. Now I'm going to, once I've isolated, I'm changing to log or exponential form. So I start with my base, begin with base. So 3 raised to the third power equals 2x minus 1. Make sure when you cube 3, you don't put 9. It's 3 times 3 times 3, which is 27. Add 1. You get 28 equals 2x. So x will equal 14. So looking here, that's going to make it a positive there. You can also type that into the calculator and check it. Make sure the left side equals 11. Okay, just another way of solving a log equation. So you can use your log base and change it to an exponent. using the same base of your log, or you can rewrite it in exponential form. Okay, we have a word problem here. We're going to go ahead and do this. The Richter scale is used to measure the magnitude of earthquakes. Scientists use the equation log of E equals 4.4 plus 1.5 m to calculate E, which is the amount of released energy in joules, in relation to the earthquake's magnitude m. How many joules of energy are released during a magnitude of 3? So I'm going to plug in, since I'm given the magnitude, I'm going to plug that into M. Okay, so I'm going to work out this side, 4.4 plus 1.5 times 3. You should get 8.9. And then I'm needing to solve for E, which is the amount of released energy. So this is a log equation. You can use whatever method you want. So I'm just going to look at my base. It's 10, so I'm going to do 10 raised to the log of E equals 10 raised to the 8.9. So the reason I did that is because those cancel out. I'm left with E. And so on the calculator, all I would need to do is 10 raised to the 8.9 power, which is 794 point, not point, comma, 328. A very large number, and that's in joules. So I just typed this into the calculator. You could have also changed this to exponential form. You would have got 10 raised to the 8.9 equals E, which is the same exact thing that we ended up getting. Okay. Last method is solving by graphing. So first you're going to graph the left side, graph your right side, and you're finding your points of intersection. Very similar to what we were doing when we solved the exponential equations graphically. So function 1, I'm going to type in log base 2 of x plus 1, and then my right side is 3. So I'm going to go ahead and do that. So go into y equals, clearing out what we have. We're typing in log base 2, so I need to do math up, log base, changing my base to 2, and then inside parentheses. All of it needs to be in parentheses because there's parentheses on my paper. And then I need a 3. So I'm going to press graph. Remember to find that point of intersection. You are doing second calc or trace. Number 5 is intersect. Press enter 3 times. And you end up getting 7, 3. So go ahead and plot that on your paper. So 7, 3. And looking back at that graph, we need to sketch it. We have and that was 7, 3. So point of intersection 7, 3. We're solving the equation, so just x equals 7 would be your solution there. So those are the different ways of solving a log function or a log equation. So finding x. If you have any questions, please let me know.